Galileo named it Aurora Borealis, but the truth behind the northern lights runs far deeper than myth. What appears as a shimmering color is actually a cosmic collision. The sun hurls charged particles, and Earth's magnetic field pushes back. It's a silent battle, written in light. For thousands of years, people believed they were spirits, gods, or omens, and maybe, in a way, they were right. So when the sky ripples with green and violet fire, ask yourself, are you witnessing beauty? Or a warning? Let's unravel the truth of what's really dancing above our heads. The sun's fiery influence. Somewhere above your head, about 93 million miles away, a storm is brewing on a star that's been burning for over 4.6 billion years. It's the source of all life on Earth, but it's also the reason the skies near the poles explode into hypnotic waves of glowing green and pink. That star is the sun, and it's far more than just a ball of light in the sky. Every second it releases streams of charged particles, what scientists call the solar wind. Sometimes the sun gets a little angrier and launches coronal mass ejections, powerful outbursts that hurl billions of tons of plasma toward our planet. You don't see this happening, but when that high-energy wave hits Earth's magnetic field, the impact is anything but silent. This interaction sets off a dazzling reaction in the upper layers of our atmosphere, sparking what we know as the northern lights. It's not magic, it's science wrapped in wonder. These solar winds travel at over 1 million miles per hour, yet instead of destruction they paint the night sky in glowing whispers. Makes you wonder, how can something so violent look so peaceful? And what else is our sun capable of that we don't even notice? Earth's magnetic shield. Think of Earth as having a hidden force field, constantly working behind the scenes to protect us. This invisible armor is the magnetosphere, generated by the molten iron swirling deep within our planet's core. Without it, we'd be bombarded by cosmic radiation every day, but here's where it gets wild. This same shield doesn't just protect us, it creates the stage for one of the most breathtaking shows in the universe. As solar particles slam into the magnetosphere, they're guided by magnetic field lines straight toward the poles, almost like a funnel. These particles spiral down into the upper atmosphere, where something beautiful happens. They crash into molecules of oxygen and nitrogen and transfer energy, causing the atoms to glow. It's as if Earth turns incoming cosmic threats into celestial art. And the magnetosphere? It's not static. It flexes, shifts, and pulses, changing how and where auroras appear. If you've ever seen the sky light up in waves of emerald and violet, you were watching the magnetosphere in action. It's not just a protective bubble. It's the conductor of Earth's own cosmic symphony. Why does it happen mostly in the north and south? That's the mystery of the poles and magnetism we're about to unfold. Atmospheric collisions and light emission. A single particle traveling millions of miles from the sun enters Earth's atmosphere, and in the blink of an eye the sky begins to glow. This moment, invisible to the naked eye, is the birth of the aurora. But what really causes that mesmerizing color display above your head? It's a science experiment on a planetary scale. As charged solar particles crash into atoms of oxygen and nitrogen in the upper atmosphere, they transfer energy, causing these atoms to get excited. And just like people, when these atoms calm down, they release energy. Only in their case, that energy comes out as shimmering light. Oxygen creates the vivid green most commonly seen in auroras. At higher altitudes it can even produce deep reds. Nitrogen, on the other hand, throws blue and purple into the mix. This interaction is so delicate that even slight changes in altitude, temperature, or atmospheric composition can shift the color palette. What's even more fascinating? These auroras occur between 80 to 300 kilometers above Earth's surface. That's not just high, it's near the edge of space. So the next time you see those glowing ribbons across the sky, remember, they're born from atomic collisions and cosmic energy dancing above our world. The dance of the auroras. The sky doesn't just glow, it moves. Those vibrant streaks of color weaving across the night aren't still images, they're alive. Shimmering, rippling, swirling like some ethereal being is painting across the stars in real time. But what causes that graceful dance? It all comes down to how Earth's magnetic field interacts with fluctuating solar winds. When the solar wind strengthens, it tugs and distorts the magnetosphere, creating magnetic substorms. These disturbances send waves of energy through the field, causing auroras to stretch, bend, pulse, and explode in motion. What's mesmerizing is how unpredictable it all is. No two aurora displays are ever the same. One moment the sky might be quiet and dark, and the next, Streaks of emerald and violet burst into view, twisting like curtains caught in a cosmic breeze. Indigenous cultures once believed these lights were spirits dancing, and honestly, it's not hard to see why. There's something deeply spiritual about watching the sky move like that. It's a reminder that our planet isn't just floating silently in space, it's interacting, responding, alive. And when the auroras dance, they're telling you a story that began on the sun and ended right above your head. Variations across the globe. Standing under the Arctic sky, people are often stunned into silence by the aurora's glow. But did you know there's a twin light show happening on the other end of the Earth? While the Aurora Borealis graces the northern skies, the Aurora Australis, or Southern Lights, lights up Antarctica and parts of the southern hemisphere. It's the same breathtaking phenomenon, just a different stage. And here's where it gets even more intriguing. Although most commonly seen in countries like Norway, Sweden, Finland, Canada, and Alaska, strong solar activity can push these lights farther south than usual. People in Scotland, northern US states, and even parts of Europe have caught surprise displays. In rare events, auroras have been seen as far south as Texas and southern China. The reason comes down to how Earth's magnetic field lines bend and stretch. Solar storms can temporarily distort these lines, allowing charged particles to dip lower in latitude than usual. So no, you don't have to live near the Arctic to witness this miracle. But you do need timing, darkness, and a bit of luck. The sky may just light up when you least expect it, and for a moment, the world above you feels vast, alive, and wild. Observing the northern lights. There's a moment when the night sky falls completely silent, and then it begins. A faint shimmer at the horizon, a soft glow, and suddenly the heavens ignite in color. Catching the northern lights isn't just about showing up, it's about understanding when and where to look. The best displays happen during winter when the nights are long and dark, usually between 10 p.m. and 2 a.m., but location is everything. Head north, far north. Remote areas in Alaska, northern Canada, Iceland, or Tromsø in Norway offer the clearest views, away from light pollution. But even then, the aurora doesn't perform on command. You'll need patience, clear skies, and a check on solar activity forecasts. Websites and apps track space weather, yes, that's a real thing, and alert you when geomagnetic storms are likely. And if the conditions align, what you see may change you. People often describe it as spiritual, overwhelming, and unforgettable. The sky opens up, and for a few minutes Earth feels suspended between worlds, touched by both the solar wind and the breath of the cosmos. No photograph can fully capture it. You don't just see the aurora, you experience it. And that moment, it's pure magic forged in science. Auroras on other worlds. Earth isn't the only place where the skies come alive with dancing lights. Across our solar system, other planets experience their own versions of auroras, and they're even more powerful, vibrant, and strange than ours. Take Jupiter, for example. This gas giant has the most intense auroras in the entire solar system. Why? Because of its enormous magnetic field, over 20,000 times stronger than Earth's. And unlike Earth's auroras, which are triggered mainly by solar winds, Jupiter's are fueled by something unexpected, its moon Io. Io is volcanically active and spits out charged particles that get trapped in Jupiter's magnetic field, sparking massive auroral storms at its poles. Saturn, Uranus, and Neptune also put on auroral shows, each influenced by their unique atmospheres and magnetic quirks. Even Mars, with its weak magnetic field, displays faint auroras, whispers of what once might have been. What this tells us is profound auroras are not just an earthly wonder, they're a cosmic language, a sign of planetary magnetism and atmospheric interaction. When you look up at Earth's northern lights, you're witnessing something that echoes across the universe. The sky is alive, not just here, but on worlds we've barely begun to understand. The universe is full of mysteries waiting to be uncovered, and tonight, you've just touched the edge of one. The northern lights remind us that even in darkness, beauty can erupt from unseen forces. If this journey lit a spark of wonder in you, don't let it fade. Join us as we explore more secrets of the cosmos, one story at a time. Drop a comment. What's one mystery you've always wanted to understand? And if you love discovering the extraordinary, make sure to like, subscribe, and hit the bell icon for more adventures, only on InnoVision Tech.